For that, which one is again from this three one is best, we can have to do another roles. Then it has best accuracy within 30%. Look at this table. 99.4 to by the way, score S is the score, the prediction, it's not the prediction, but the score of genetic iteration is 97.74, but the prediction accuracy is 99.42 within the confusion matrix as shown. And in addition to that, we can add precision, recall, and F1 score also shown in the logistic regression is 1.0 or the F1 score is 0.991 for zero type 0, which means malignant and benign prediction is 1.0 and 0.99. So that as shown here, it is after implementing PMP, we have got good, preferably good accuracies, and we have it better performance. The difference also from with before applying PMP and after 2% increments and 1%, 2% with different classification algorithms. Here's also as shown in the diagram, the LR is highest accuracy with genetic implementing genetic algorithm. Here's also the F1 score difference. Yes.
Beyond your time.
Okay, thank you. Just let me summarize it. The genetic algorithm, one is the computational algorithm for optimal problem. In this paper, we're not adding the minimum mathematical model, we add it. And the selection method, selection-based crossover by differentiating different methodology, we may have it additional performances so that for future paper or future researches, this is open, and by implementing the PMP, we can have it a better performance in genetic algorithm. Thank you very much. Sorry for the time.
Thank you, Ababa, for a well designed presentation, also interesting work. Any questions from the audience? We have about 7 minutes.
I think there's a question by Samuel.
Yeah. Samuel, please go ahead.
Yeah, thank you, Abdullah, for a nice presentation. I want to be clear with some of the topics you raised. First of all, I think you are using the genetic algorithm, from my understanding, for feature selection. So, uh, how many features finally selected from the available 31 features? Maybe through the genetic algorithm. I think the idea is to reduce the number of features so that the performance is not affected and uh, the classification is fast. So that's my understanding. Can you answer this one?
Thank you very much. As I've mentioned, the first two data before pre-processing, and after that, correlation and pre-processing has done, and finally, the final feature is 12 of them has done from those 31 features and putting it to the PMP.
The genetic algorithm is not used for feature selection.
No, before all of them 31 features, there is a difference, and then after 12 there is also a difference. But after applying on this PMP on those 12 features, because why I'm doing this correlation is to reduce the feature which has similar. One is reduce all of them, and it of course it has its own advantages using genetic algorithm. My aim is to enhance or additional accuracy to add PMP. By itself, genetic algorithm is good. Doesn't mean that it's not good for feature selection.
Okay, so let me come to my second question. So if you have reduced the number of features and and also you are improving the accuracy. So most of the time, feature selection might somehow affect the classification performance. That is, why do you think it's better with feature selection?
Sorry, sorry. Why? Why not? Hello?
Why do you think it's become it becomes better with the reduced number of features, the classification?
No, no. My aim is I'm doing this fitness is the fitness selection is doing for the training purpose, the prediction ones. Selection is has done only the classification has done within the LR parts or different algorithms. May I answer your question? I'm not sure.
Looks like we lost Samuel or something. Okay. Um, any other question? If people don't have any question, I have a question. Okay. So, so you're using the genetic algorithm for a better feature selection, and you use that with other machine learning algorithms to improve detection. So, how effective is that? Like what I'm saying is like what the end result? How does it compare with other works?
Okay. By the way, I have another paper already. I did genetic algorithm comparing for the other algorithms, and then I've got it for minimum data, which is as you have seen here, it is 569 data is very minimum. With
Yes.
to yes, that one is better. Instead of deep learning, for example, it needs a huge data set, and one of the advantages genetic algorithm. With this small data, genetic algorithm is it's better because I have it another analysis I did. On this genetic algorithm, I'm adding additional mathematical by changing somehow mathematical model and enhancing the accuracy part. That's why I'm doing.
Yeah, what do you mean by accuracy? Because, like you were saying earlier, you're not using
Ah,
the genetic algorithm for classification, but you used it for feature selection. So, which like you use some method for the classification, right?
features. Yes, classification, and then the training part is called classification plus then the training is there. So the training should have more accurate the prediction and then the actual results. So that's
And
what I
what
meant. The
method did you use
prediction.
for that?
Yeah.
For the
Sorry.
prediction, what did you use?
The prediction genetic algorithm by itself, genetic algorithm.
Uh, I thought the genetic algorithm was used for feature selection.
Feature selection plus and then training it there.
Oh, so you just used genetic algorithm for the entire pipeline. You used it
The
for feature
entire part.
selection, and then you used
Yes.
it for like
Training.
classification as well. Okay.
Classification, no, classification additional different. For example, as shown, logistic regression, KNN, SCVM, these are for classification purpose we use it.
Okay.
Yeah.
Slushy. Next question. Slushy. Mr. Daniel, can you add Slushy to be able to talk? Yes. Slushy.
Yes, can you hear me?
Yes, we can hear you.
Yes.
Oh, okay. I'm really concerned about. Okay, first, thank you for your presentation. It's a nice presentation, and uh, as somewhere and you side, the chair side, I get lost with the application of genetic algorithm on which stage of the pipeline that the genetic algorithm was useful. Uh, and I want some clear information about that. That's my question. Thank you.
Okay. Oh, on my presentation also, as I have here, the logistic regression and the other are for using classifications. By combining, hybriding this logistic regression with genetic algorithm, we can have it through the process of training parts, training, and then prediction will be done by that. But the other logistic regression and other for classification, or the feature selection and training has done by the genetic algorithm. May I answer your question?
I think you used the objective function, these models uh, inside your genetic algorithm. You use this logistic regression and the CVM for as objective functions, and you get the fitting models after that. And I think that's what we call by classification, right? If I didn't get wrong.
Yeah, yeah. Yes, yes.
That's how you classify the results or you detect the anomaly.
Yes, of course.
Okay, okay, okay. Thank you very much. That was my
Thank
question.
you.
Thank you, Sulashi, for the question, and thank you, guests and Professor Akim. I think time is now for tea break. So
Yeah.
we will break for 18 minutes,
Before the tea
and
break,
we
uh,
yes.
can I continue? I'm Daniel. Before the tea break, the next presenter
Uh-huh.
after the tea break is not available, Kader Hussein. So if Batamart is there, it is better to continue from her.
Ultimate.
Batamart, yeah.
Okay.
Then Daraja. So
Okay. I don't see her in here, but unless
yeah.
she came in with a
Uh,
different
if
name.
if she's
Um,
not here, I have her video. We'll play her video.
I think
okay. I
we
think
should
we
wait
have her
for
number here. We could
Rebecca.
give her a call.
Yeah.
Don't worry. Okay. Anyways, everyone, be back here at 3:35,
Okay.
right? And 2:35 for our people from abroad. Um, so we'll see you in 17 minutes now. Yeah.
Okay. Thank you.
Yeah. Bye.
Traditional reinforcement methods cannot find the optimal policy benefit. So that the deep reinforcement learning to handle high developed to handle high dimensional environmental based on the deep neural network. Employment of RL in IoT. Multiple research works adopted for RL and DRL technique to enhance IoT system operation or resolve some of the issues like routing, scheduling, resource allocation, dynamic spectrum access, synergy, and mobility. Actually, after this, my presentation will focus on this, how the machine learning or reinforcement learning have been applied on this advantage in terms of business. And here are some of our vision on routing, like just as per this, for instance, when you take decentralized reinforcement method machine learning type have been employed for just to improve the performance in high load conditions of by applying the Q learning scheme in reference 17. The Q function table does not scale well to large networks. It's taken as the limitation. And reference 19, decentralized reinforcement learning based on the neural network and Q learning have been applied to improve the scalability of the Q function. And but its limitation not scale with some network cases. So it should be have to be categorized. And machine learning in scheduling, actually, we have also reviewed some papers in machine learning and scheduling. For instance, reference number 21, the SARSA modified is used to detect target, send message, and predict the trajectory intersection by having a reward of just related to residual energy, maximum energy level, and the number of field of view detected target's position in the wireless sensor network. And also, the Q learning have been also used to enhance the transmission and acknowledgement successes in the cell in wireless sensor network by select an active slot for the current frame using and employing the Q learning mechanisms. And machine learning for resource allocation, actually, just we have reviewed two papers in machine learning for resource allocation, the transmission rate and consumption transmission power by applying Q learning in reference number 25. And in reference number 26, just the author is used to improve the percentage of gain of network performance metrics by selecting a MAC protocol as an available resource and how to share it in wireless network. In wireless network. Machine learning in dynamic spectrum access, actually the dynamic spectrum is a policy that specifies how equipment can efficiently and economically share the available frequency while avoiding interference between users. So the machine learning algorithms have a remarkable improvement in latency and throughput performance based on by applying these principles. So just reinforcement learning and deep reinforcement learning to solve the dynamic spectrum access problem focuses mainly on the network where communication traffic is changing and unknown. And machine learning in energy efficiency, actually, for a better for battery powered devices in IoT system, optimizing energy consumption and improving network lifetime are fundamental. A transmission power control approach has been proposed to adapt by learning the transmission power value in different conditions. However, it has a high probability of packet loss. Energy harvesting is an alternate process to provide some energy to the code, to the nodes. In contrast, energy harvesting brings a new challenge to the energy management, how to maximize the harvesting power and energy use efficiency. The existing work have shown that the application of RL and DRL approach allows to extend notice lifetime and improve harvesting in network systems. Machine learning in mobility, several IoT devices rely on low-cost hardware and they are not equipped with location sensors. Therefore, an intelligent system RL and DRL approach must be integrated into mobile nodes in order to find the optimal trajectory to follow. So the just machine learning approach to manage network topology and collect data through mobile networks. Well, challenges of IoT machine learning in IoT, actually we have found investigated as a security challenge because and the privacy challenges are available while this point of view. And energy efficiency is also, it doesn't mean energy efficiency even if some machine learning techniques have been utilized to develop the energy efficiency of IoT devices. However, it is still there are some improvements required. The contribution of this work, actually a detailed overview of machine learning in IoT have been done. An overview of different machine learning algorithms for routing, scheduling, resource allocation, energy efficiency in IoT have been done, and explores an open research challenges in machine learning in IoT. As a conclusion, recent articles used in machine learning approach in wireless IoT context were covered in this article. And initially, a wireless, a summary of wireless network and machine learning approach is presented. And in addition, we summarize the use of techniques, state, space, action, space, and reward function for each study. And it is essential to note that these solutions are useful for resolving a variety of challenges in IoT networking and communication operation, but further work is needed to address the security and the privacy concerns in IoT. These are some of our references we have utilized while preparing our documents. And this is the end of my presentation. Thank you. And if you have any questions,
Okay, Fira, can you play the next one? Hello, Fira? Is someone? Hello? Hello?
Sorry, Dr. Bakal. I was searching for his video, but the next presenter video is not available. So
Okay, so
we can proceed to the last presenter. If he's available, he can continue. I think Khalid
Kalisa?
is, yeah.
Sure. Okay. Kalisa, are you available? Just give me sign. Khalid Isa. Yes, he's available. So please share your slide and also introduce yourself so that we can know you, what you do, what are you doing currently, so that we can at the same time also network and talk about future works. I give the time, you can share your slide and we proceed.
Is my voice clear?
Yeah, it's clear. Your slide is visible. Yeah, you can continue.
Okay. Hello, everyone. My name is Khalid Aissa. I'm a computer engineering student at the German University in Cairo. Today I'm presenting my thesis, Fake versus Real Face Discrimination using CNNs for the Pan-African Conference. This was done under the supervision of Professor Dr. PanAfricon in University. This is the content of the presentation. First, we'll start a brief introduction to the problem. There has been many rapid advancements in the image manipulation and forgery since the rise of general adversarial networks, also known as scans and deepfakes that can generate highly convincing images that can deceive top classifiers and even human beings. And digital interactions are changed every day by this evolving technology by posing different threats, such as security, privacy, and authenticity threats, which created a high demand for more accurate and robust face identification systems. And these discrimination systems are always being challenged by this evolving technology, as there are many variations now of gens, for example, style gen, PG gen, and so on. So in this, we're going to explore the real versus fake face domain by proposing techniques. Specifically, we propose three CNN model architectures, and we compare them with state-of-the-art CNN pre-trained models such as Inception ResNet V2, ResNet 50, DenseNet 1-to-1, and EfficientNet B2. We compare the results based on validation, training, testing results, and the generalizability based on a dataset where the fake part is generated from a style gen. Here are some of the state-of-the-art approaches. Most of these state-of-the-art approaches had some gaps. For example, limited generalizability. Most of them did not generalize on new unseen data. Most of them were time-consuming and hard to be deployed in real-life scenarios, and some of them relied on having multiple gens, which may not be applicable and may be also time-consuming. We also use convolutional neural networks as our base solution for this problem. And also the main, let's say, loss function we use is the binary cross entropy loss function, since it's a binary classification problem between the fake and the real. The main activation function we used was the switch activation function. It was used after every convolutional operation layer. Also, we used two regularization techniques, dropout and L2 regularization, in order to address overfitting, because some of the models had overfitting problems. And the main optimizer we used during the training process was the Adam optimizer. Also, for pre-processing methods, we used pixel rescaling to rescale the pixel values to a range of 0 and 1, so that input features have similar magnitudes. And this offered numerical stability. Moving on to the methodology, first we'll talk about the dataset we used. We used the 140,000 real and fake faces dataset, which includes from the name 140,000 face images. And from the image, we can see that it's split into 70,000 fake face images and 70,000 face real images. The dataset is split into three datasets. So inside it, there are three, let's say, directories. The training dataset includes 100,000 face images that are split evenly also to 50,000 fake and 50,000 real. The validation is 20,000 images that are split evenly into 10,000 fake and 10,000 real. And the same goes for the testing. Also use the GPU T4 times 2 hardware accelerator, which is basically T4 NVIDIA, but however they are two in our training process. And moving on to the settings for the proposed models, the input size was 224 by 224. The Adam optimizer was used with this learning rate. Binary cross entropy was the loss function. The batch size for the training and validation dataset was 64. However, for the test dataset, it had a batch size of 1. L2 regularization was applied in the second fully connected layer in the three proposed models we came up with this factor. Switch activation was applied after every convolutional layer, and the activation function for the last layer was the sigmoid, as it is a binary classification problem. Also, pixel scaling is applied. Moving on to the architecture, this is the first model. We can see here that the kernel sizes for all the convolutional layers is 3 times 3, and the pooling size for all the pooling layers was 2 times 2. Also, we can see that the switch activation is applied after or alongside with the convolutional layers, and dropout is applied after every convolutional layer. And also, it is applied in the second fully connected layer with factors of 0.25 and 0.5. Also, L2 regularizers are applied in the second fully connected layer. And this model was trained on a subset from the training dataset, which was around 40,000 images that are split evenly into 20,000 fake images, 20,000 real face images. And this was trained for 12 epochs.
335.
For the second model, we adjusted the architecture by adding a convolutional layer followed by max pooling layer. However, the last max pooling layer had a different pool size of 3 times 3. This is in order to reduce the spatial dimensionality of the output. And all of the dropout factors in the model were adjusted to 0.25, so they were reduced to see the effect. And this model was also trained on a bigger subset, which was around 50,000 face images that are split evenly into 20,000 and 20,000. 25. And this model was trained for 13 epochs. For the third model, it had the same architecture as the second model. However, we adjusted the dropout factors to be 0.1 and 0.2 seen here and in the second fully connected layer. And this model was trained on the whole training dataset, which was around 100,000 face images that are split evenly into 50,000 50,000 real. And this was trained for 15 epochs, so increased the number of epochs to see the effect. Here are the settings for the pre-trained models. It had similar settings to the previous proposed models we came up with. However, we did not use any regularization techniques in this. Also, the same sigmoid function at the last layer, pixel scaling is applied, And all of these models trained for 15 epochs and were trained on the whole training dataset. We can see these are the architectures of the pre-trained models: Inception ResNet v2, ResNet 50, DenseNet, and EfficientNet. And we can notice from all of the figures that all of them are connected to a global average pooling layer after the output of every, let's say, model, in order to reduce the spatial dimensionality of the output and to try to reduce the complexity of the model. After that, we calculate the following evaluation metrics in order to compare between all models, including accuracy, fun score, and so on. Moving on to the results and discussions, here is a model parameter comparison between all models. We can see that the first model, for example, had around 100 million parameters, which is large. Moving on, we have the training time statistics comparison between all models given in seconds, including batch time, single epoch time, and so on. Here are the results for the first model. We can see here that this is the loss and accuracy graphs during the 12 epochs for the training process. We can see here that the orange curves are the validation curves and the blue curves are the training curves. And we can notice from this is not smooth at all. It has high number of oscillations or zigzag pattern. This can be due to the fact that this model had a hard time converging to the optimal point and was complex. It had around 100 million parameters, so it had many, let's say, problems going up and down. However, the accuracy graph was a bit smoother and it ended up with a validation accuracy higher than the training accuracy, which gives a good sign that this model actually goes or generalizes well. This graph shows the prediction probabilities when we feed the test dataset to the first model. As we said, the first dataset is around 20,000 images that are split even into 10,000 face real images and 10,000 fake face images. The blue part is the real samples and the orange part is the fake samples. We have the classification threshold as 0.5, meaning that everything above the classification threshold is real and everything below it is a fake. So for the real part, we can see that 9,097 real samples were misclassified or they were classified correctly above the threshold. However, the rest of the 903 real samples were misclassified below the threshold. So yeah, and this goes for the fake part also. And this can also be illustrated by the confusion matrix. We can see here the false negative and the false positives as they are illustrated in the below and above here. And this is the ROC curve for the first one. After that, we calculate the evaluation metrics, and we end up with a total overall accuracy of 92%. However, there is a note here to be noticed that the accuracy here is calculated from a different, let's say, equation, and we will get to that later in the presentation. For the second model, we can see that the training curves, as the blue curves, which is the training curves for both the accuracy and loss, are much, much smoother and did not suffer from any oscillations. So this model had a better time in the training performance. However, the validation curves are not that well and had this same zigzag pattern going up and down, maybe due to the fact that this model does not generalize that well on new unseen data. However, at the end of the 13 epoch, you can see that it reached a good loss value and a good accuracy value. So yeah, it reached a good, let's say, performance at the end. Here are the prediction probabilities for the test dataset when you feed it in the second model. We can see that the number of misclassifications in the real and the fake part are much, much less than in the first model. And this also can be illustrated by the confusion matrix. And this is the ROC curve for the second model. Also, this is the evaluation metrics for the second model. You can see it reached an accuracy of 97%, which is better, alongside with better precision recall values. Moving on to the third model, we can see that the loss and accuracy graphs for both the training validations are much, much smoother. The number of oscillations are now much, much less, and we can see that the zigzag pattern is not that visible. And this model is the best in terms of the validation and training, and it reached a better, let's say, results than the first two models. Here are the prediction probabilities when we feed a test dataset in the third model. We can see here that the number of misclassifications in the real and in the fake part is much, much less, and the graph for the probabilities is much smoother and much cleaner. Also, the results here we can see the ROC curve and the confusion matrix. Also, the number of false positives here is the same number as the false negatives. So this model has asymmetrical behavior and does not have a biased behavior, means that it does not tend to misclassify in one class more than the other. And here are the evaluation metrics for the third model. We can see it's a better, let's say, values, accuracy values, precision values, and so on. Moving on to the results of pre-trained models, we can see that the curves for the loss and accuracy graphs are not that sharp. However, we can notice that from the blue curves for all, that these are the training curves, and for the loss and accuracy, that they are smooth, and the training process did not suffer from any, let's say, difficulties, and did not have any, let's say, hard time converging to the optimal point. However, for the validation curves, it had these big oscillations going up and down, and the zigzag pattern was significantly bigger than the first three models we noticed. This may be due to the fact that these models are complex, contain a high number of, let's say, layers and parameters, so can be a factor to that. And also, some of these models were overfitting. For example, the Inception ResNet V2 and ResNet 50. We can see here that the validation accuracy in the last epoch was much lower than the training accuracy. The same goes for the ResNet 50. Here we can see the prediction probabilities when we feed the test dataset into the, let's say, pre-trained models. We can see good results. However, we will notice something in the next slides. Here are the ROC curves. Also, they are considered great. And from the confusion matrix, you can see here that the false positive rate is much higher than the false negative rate. So we can notice this in all, let's say, confusion matrix of all the pre-trained models. And this can be seen here that the false positive rate is much higher than the false negative rate. So this means that the number of misclassifications in the fake class is much higher than the number of misclassifications in the real class. So there is a biased behavior in all pre-trained models, which affects the classification process. And here are the results of the evaluation metrics for all the pre-trained models. You can see the accuracy is ranging from 97% to approximately 100, but we'll get to that later. We saw that the accuracies in all of these tables were calculated using this formula, which uses the true positive, true negative, which are the confusion metric attributes. However, for better estimation, we use the following, let's say, formula so that it will give us a better estimation. It is basically a standard measurement. And when we do so, we find that the accurate values for the overall accuracy is the following. And yeah, you can see here that the third model had highest amongst the let's say, three proposed models, and the best overall test accuracy was the efficient net B2, which was around 99%. Finally, we did the generalizability test, which is a comparison between all models using 10 random face images, 5 fake and 5 real, where the classification threshold is 0.5, so everything above it is real and everything below is fake. When we do so, we find out that our three proposed models had the best accuracy, with accuracies around 90 to 100%, meaning that they classified 100% of these images correctly. Only the third model misclassified in the last fake image. However, for the pre-trained models, we can see the accuracies are ranging from 60 to 80%, meaning that they misclassified a lot. And there's another notice here that we can see is that all of the pre-trained model misclassified in the fake part only. So we can notice further the biased behavior that we talked about, as they tend to misclassify more in the fake class. So this brings us to the conclusion. To summarize what we did, we explored the fake versus real domain by proposing several, specifically three CNN model architectures, and we compared them with state-of-the-art CNN models such as Inception ResNet V2. We found out that the third model had the best performance, had a best compromise between training, validation, and generalizability performances. Overfitting occurred in most pre-trained models, especially Inception ResNet V2 and ResNet 50. Biased behavior is seen in all pre-trained models, where the number of misclassifications in the fake class is much higher than in the real class. Best performing pre-trained model was seen as the DenseNet, as it offers the best performance between generalizability and training validation performances. Limitations were the hardware limitation, as the hardware had limited time to be trained on, so training took more time than it should have been. And the dataset did not include a wide variety of fake samples, it only included samples from style gens, so yeah. Future recommendations would be utilizing a dataset with a wide variety of with a wide range of fake samples from different gens, for example, style gen 2, PG gen, and so on. Adjusting library parameters, for example, dropout factors, number of epochs, and so on. Increasing the number of pixels to include more details into the picture. Also experimenting with, let's say, different light color settings such as grayscale and so on. And using ensembles can be a good idea to combine several models together. Here are the references for the presentation, and yeah, this concludes my presentation. Thank you.
Oh, and thank you very much, Khalid, for your detailed and very really nice presentation. If anybody has questions, please raise your hands, and I'll give you the chance. Any question or any suggestions or comments, you are welcome. Any question? Okay, so can I ask one question, Khalid?
Yes.
You mentioned one of the problems with pre-trained models is they overfit, right?
Yes, exactly.
I'm wondering which, like the pre-training models and the ones the data sets which you want to apply, are they of, uh, do they have similar characteristics or how are they?
For the pre-trained models, only the ResNet has similar characteristics. They contain something called the residual blocks, where,
Okay.
yeah. However, for the rest of the pre-trained model, for example, the efficient net, it had a pretty, let's say, different architecture from the rest of them. And yeah, which occupied the best performance. Yeah.
Okay. Oh, that's nice. Actually, I was also wondering if they're the same, then you can only suppress few layers. Okay, you can suppress most of the layers, but if they are different, then you need to retrain most of the layers, and only you transfer few parameters from probably the from the beginning layers. So I'm wondering if you did experiments on how you can also tweak the number of layers you have to suppress and you have to again retrain, and if you have such experiments and how you found out in your research.
I only transferred around, I think, 400 layers for, because these models are relatively have a high number of layers, so it had like to maybe extract some layers that are unnecessary. But most of them, like for example, the DenseNet did not have that much layers, so I basically like took the whole, let's say, model with all layers. However, I tended to adjust some, let's say, for example, add the global average pooling layer to reduce the dimensionality of the output.
All right.
And yeah, this was the only thing that was adjusted in the pre-trained layers.
All right. Thank you for your answers. Anyone who has questions before I make the final remarks? Firal, is there anything that you wanted to say before?
Okay, Dr. Bakal. Thank you. I think our next presenter from Stellenbosch University, South Africa, Mr. Luis Kaplan. I think he's available. And
He's available. Okay, he came.
he's
Okay,
now with us.
good. Okay, nice. So let him present, and then we do final remarks. Okay.
Okay. Thank you. Luis Kaplan, I think you can continue. Unmute yourself.
Okay, can you make me the presenter, please?
Sorry?
I say, I've got my
You can
PowerPoint
share your slides
on
and
my lap.
can continue.
No, give him a presenter privilege so that he can share his slides. I
Yeah,
think
yeah,
that's what.
yeah. I already gave him. Okay.
Okay, cool. Okay, am I coming through there? Can you see?
Yes, we can see clearly. And
All clear
introduce
and you can
yourself.
hear?
Also introduce yourself
Right.
so that we can know you more. All right.
You can see the slides. Fantastic. All right. So my name is Lewis Kaplan from Durban, South Africa. We're on the coast here, and we're starting to get extra warm days are occurring. Anyway, the presentation that I have for the conference today is titled "Whose IP is it anyway? Intellectual Properties and AI for Securing the Value Chain of Knowledge." Now, my name is Lewis Kaplan, and my co-authors for this presentation are Emily Thiel, who's online, and Bruce Watson. We're all from the Center of AI Research, School for Data Science and Computational Thinking from Stellenbosch University. So a very warm welcome from us here in South Africa and especially in Durban. And I hope you enjoy our presentation, which has a slightly different um, direction to many of the presentations that I've heard today. Now, what we looked at here initially, and this is more of a concept paper, which is aiming where in fact we are aiming to implement some research, direct research, and to test the systems that we are proposing here, is we've got intellectual property that flows through our supply chains. We've got supply chains moving all over the world, and it's very difficult to pin these supply chains down. But the supply chains are also responsible for adding value to our products and services. But whilst they're also adding value to the products and services for whoever the end customers are, there's the concept of knowledge being generated within those supply chains, and that has got huge amounts of value. When I talk about value, it's very difficult to define the concept or the term of value, but everyone knows in their own inimitable way what we mean by value. And that value is being generated along the supply chain. And whilst it's being generated, there's a huge group of actors out there from different governments across the world, and also from maybe other companies who want to get their hands on this thing called knowledge. Now, what are we doing about it? Because the concept of intellectual property in the last sort of 300 years has become a very crucial, pivotal area in adding value within our supply chains. And I looked at it from the point of view of if we remove just one element of intellectual property, whether it be a patent or whatever the case happens to be, that will have a huge constraint of that supply chain, either enable it to continue, or it would then, by who's ever taken that little piece of intellectual property out of the system or taken it for their own use, it would then enable them to compete. Is IP unfair? I don't know. That's a philosophical discussion for another day and another time. So if I have a look at it in terms of the particular concepts here, we've got IP, and we've got value chain, and we've got the area of knowledge. Now moving onwards and upwards. How do we know who owns the IP? Well, we pick up a book, we pick up a register, and we can then find out whether that intellectual property has been registered in a country in some shape or form. Not all companies adhere to laws and rules. So really we're looking at a concept paper of new methods of solutioning intercepts for AI. In other words, where should we aim our AI at? We've got this phenomenal tool now
called artificial intelligence, and it's being improved daily, weekly, monthly, and so on. And we want to now start to use it to plug the gaps, to plug the leaks. Because in order to have suppliers, customers, and people involved in adding value within the supply chain, they want to be certain in some shape or form that their information, their knowledge, their payment systems, etc., are secure. Now, with the vast amount of code that has been generated already up to this point in time, it's now becoming incredibly difficult for individuals to track the code. So now we have to automate it in some shape or form. You see, if we look at the concept of digitization, yeah, a lot of stuff is digitized. And the more it's digitized, the more code there is, and then the more difficult it is to actually find the leaks and to plug the leaks. So what is intellectual property? If we look at some very typical legal definitions, it encompasses patents, copyright, trademarks, and to a large extent within organizations, they've got their own knowledge, shall we say, areas of knowledge. They've developed procedures, they've developed processes, very difficult to register, but those processes and procedures are absolutely crucial to maintaining some kind of competitive advantage. Can we define IP? Is it definable? Some people would say yes, others would say no. I'm not too concerned about going into the legal argument and discussion about defining intellectual property, but in a nutshell, it's that value, or shall we say, it's those ideas that are encompassed and registered against a particular number, or it's been copyrighted and so on. And we've got various tools for copyright, and we can also identify if there's copying on trademarks and so on. We've now got very clever AI systems that can search all the databases for similar pictures and so on. So yeah, it all depends how we want to define what do we mean by IP. There's the South African law, there's the European Union law, there's the US laws, there's laws in the UK, Japan, Australia, and other places. And those laws are embedded in those societies, and provided that people respect those laws, those rules of operation, or shall we say the rules of the game, then the IP is protected. If not, it's a free-for-all out there. There have been papers written on the stick or carrot method for organizational protection of IP. There are a number of journal articles on it. If the group or anyone would like to actually do a Google Scholar search, you'll come up with a number of these papers. How best to protect IP. But having said that, that is the basic game or rules of the game that most of us would like to live with. On the other hand, there are others who are not interested in the rules of the game, and they will do whatever is necessary to get their hands on intellectual property, procedures, processes, and systems. Now, if we look at let me just pull this up. If we look at research methodology, research methods, the very typical methods that have been taught to postgraduate students, masters, doctoral students, they're using research methods. They open a book and there's a whole range of them, qualitative, quantitative, mixed methods, double-blind studies and so on. Those are fine. Those are fine for certain kinds of operations or certain kinds of research. Now, what we're talking here about, we need to break out of the old paradigms, because what is taking place with artificial intelligence, what is taking place with intellectual property in our supply chains, they are incredibly dynamic and complex, as we all know. Now, if we look at a typical strategic analysis of the environment, there's the acronym VUCA, VUCA, and I'm sure many of you will know what that stands for. Now, it really indicates to us that the system is volatile out there. There's a lot of movement. There are a lot of attributes out there which we can identify. There are a lot of objects that we can identify. But how are we going to put those in some kind of logical manner or method to actually analyze them? Now, one of the areas that we in fact are looking at, we're going to look at the lattice network, to look at objects and attributes of whichever areas that we wish to investigate. And from the lattice, and also using large language models, we'll be able to look for potential weaknesses within the supply chain or parts thereof. It would be pretty impossible to analyze all the areas of an entire supply chain because it's very divergent and so on, and convergent in certain places. So we would then use the lattice networks to inform us of which points to where the weaknesses are based upon probabilities and the probability sciences to then target. We're not adverse to looking at statistical probabilities at what are considered to be the target points. And I think statistical probabilities and stats are still very, very crucial to our analysis. And and obviously we want to look at inferences based upon the various probabilities of the system. So again, we can then use AI if we get the AI systems pretty close to what we're looking for. We wish to obviously use them to analyze the system. Generating code. The old way of generating code was really for people to sit down and type. And type and type and type. Now, with the huge amounts of code out there, and coupled with AI now being able to generate code itself, and I've heard of, it's purely hearsay at this point in time, phenomenal advances in generating code for doing certain tasks and tools, which I'm sure many of you have heard of, but not necessarily the information has been written down because of intellectual property as well. So here we've got a concept here. We're going to say that we're going to move away from the typical research methods for our new concepts to analyze them, and we're going to be working with a lattice network. In a nutshell, that's formal concept analysis. Now, moving a little bit closer to what the title is of our paper today, we've got the global supply chains. And within those global supply chains, we're developing knowledge. Now, global supply chains, if we look at the globe in itself, we could really divide it into north and south, where sort of south from the equator, it's an approximation. We've got a huge amount of the basic raw materials being extracted. So we've got the extractive industries where there's not much beneficiation taking place here, and those products are then shipped to countries of the north. And from there, there's huge amounts of beneficiation, being added to the materials and to the raw materials and so on. Rare earth metals, for example, located in Africa as well as in China. But where's the value being added? So really, there's huge amounts of movements of information and data and money across the supply chains. And those are targets. Those are targets for data breaches. Now, the concept of visibility within the supply chains means that it's visibility for customers and for suppliers, upstream as well as downstream within the supply chain. Now, if we look at upstream goes back further and further towards the source of the materials, whereas downstream looks at more value being added. Now, customers, generally speaking, like you and I, we've got cell phones, we've got laptops, we've got different advanced products, we've got some basic products and so on. There's that movement towards the customers as well as beyond. So where and how is IP developed and infused into the products and services? And that's the multi-million dollar question. We can identify who owns particular patents. All right, that's easy. We can identify who owns the various trademarks. That's pretty easy. But IP is continuously being infused into products and services as we move downstream along the supply chain. And there's the concept of trust coming into play. How am I going to release my IP to you, the supplier, and hoping that you then are not going to sell that IP onto somebody else, and or methods and or recipes, or whatever the case happens to be? A very interesting example of this: how do you protect biscuit manufacturing within the supply chain? We know what the basics are. We know that there's flour, there's sugar, there's some butter, there's certain ingredients, there's flavorants and so on. We can tap into a lot of that. But what is crucial here is not so much the actual recipe, but it's the machinery that's used to produce the actual end product, and how it looks and its look and feel for the customer. So there's a lot of knowledge that is being created by, for example, biscuit manufacturers, car manufacturers, and so on. So remember that as soon as we start to delve into the area of where the value is, there are a whole lot of actors out there who want to get their hands on a tremendous amount of this IP. So remember that a loss of just one patent in the supply chain can really hold up that supply chain, can really affect the competitive advantage of that supply chain. Think about a patented chip that goes into the computer systems of an electric vehicle, or even of a petrol-driven car, and so on, that really controls, because these days all the cars have got a computer box, and should something go haywire with that computer box, you can't move that motor car. So all it needs is the withdrawal of that one chip, or somebody getting their hands on the integrated circuit chip and investigating and finding out what the competitive advantage is of that. It could be lower fuel usage and so on. So really, we want to look at some kind of flexible knowledge development. We want to secure contracts. We want to ensure that the products flow down the supply chains, and there's trustworthiness involved there. All right, now we move on to the area within our supply chains of this new, well, it's not a new concept, but it's now become a very critical concept, and that is the concept of trust. I'm going to put my money in the bank. I walk into the bank branch, I take a whole wad of euros or dollars or rands or whatever the case is, and I hand it over to a teller. They take the money from me, they then convert that money, which in my hands is real, and they convert it into numbers. Thereafter, we pay into the supply chain, we pay using numbers. So if we look at, for example, the M+3, which is the amount of the total money supply in South Africa, we find that approximately only 80% of the money supply in South Africa is in the form of notes and coins. In other countries, it's almost zero. Everything is everything is really in the movement of numbers within systems. So that's to put it in a very basic way. But the bottom line is we have to create digital trust within the supply chains, and we're hoping to do that via the concept of AI, because really, how are we going to test the system with people? How are we going to have enough people employed to run tests throughout the supply chain and to verify and validate where the patents are. So AI has a major transformative impact on the supply chains and within the supply chain in managing the area of digital trust. So really, if we want to understand it, we've got various knowledge systems available to us. And we're hoping that the AI systems that we're going to be looking at are going to be able to run a, shall we say, test various areas for breaches. So if we then notice the intellectual property's crucial role in the supply chain, there has to be trust. Before people inject their hard-earned knowledges, before IP is processed through the supply chain, you see, if we don't have intellectual property, we can really throw out this whole area of technology and making our lives efficient. Intellectual property has that crucial role in constantly developing new ways and new techniques of managing the technologies that are available and improving, making it faster and smoother, and less work for people, more work for machines. Also, what's happened along the way is that people have been generating code. Okay, can we protect that code, or are we going to say that we're going to use AI to really find the best way of writing code to look for breaches? Now, there are also a lot of challenges within the supply chains, and we've got a lot of shall we say we've got a large number of cyber incidences. For many of you, you might subscribe to a very nice email which comes out almost every day. It's called Hacker Day, and it's incredible the amount of data breaches that are in fact happening. And those data breaches are really for other actors to get their hands on either monies or products or knowledges. Now, what we're trying to do as well is we want to set up within the supply chain a system where the customers, suppliers, people that are dealing with those suppliers can trust the system. And one of the ways of creating some kind of systematic securing of the intellectual property is through blockchain and digital ownership. Now, you all are fully aware by now of the blockchain usage, and yes, there are data breaches of blockchain, but for now, it seems to be one of the most secure ways, one of them, of identifying ownership, ownership in a digital way of the intellectual property. Excuse me. There's also the area of data analytics for proactive security. In other words, looking at analyzing the data that is flowing in and out of our supply chain and what kind of data do the other supply chains have. All right, so now moving onwards and upwards. So here we've got the transformative impact. We've got the transformative impact of AI. In other words, it's really revolutionizing, or it's a revolutionary way of generating knowledge and knowledges. We're not talking about doing its own thing. I've run a number of ChatGPT test patterns on answering questions and so on. And in some cases, it's telling a good story. And in other cases, where I've done an analysis of it, sure, it's amazing the kind of stories it tells, but there's not much truth in it. It sounds very good. So really, by using AI, we're looking at obviously identifying points, and we're looking at this concept of efficiency. How quickly can we look for breaches? Because really, at the end of the day, The word efficiency and effectiveness, you're all familiar with those two terms. The concept of effectiveness is, what does the customer want? What does the actual customer want? What do the suppliers want? They want to be able to trust the system. And for the system to be effective, we must have an efficient system to identify breaches. Now, IP is crucial. It really is incredibly crucial to ongoing development of new technologies, new ways of doing work, and so on. And as I said earlier, please rather don't think of IP just as being patents and copyright and trademarks and so on. Think of it as being huge amounts of knowledges that are created within organizations and within the supply chain. So if we've got artificial intelligence, let's just circle that as well. If we've got artificial intelligence available to us, that can enhance the trust that people would have within the supply chain system, both from customers as well as suppliers. So there are a lot of challenges in trust and security. You're all familiar with them. There's data breaches on an ongoing basis, information, IP breaches. You've got ransomware being played out. Now, we need to be able to be proactive, not reactive. And I've noticed that a lot along the way, there's a huge amount of reactive actions that are taken by organizations after the breaches have gone through. Now, we need to be doing something about being proactive, and this is where we are looking to have obviously blockchain being invoked in a more comprehensive manner, or variations of blockchain, so that we can secure the ownership of the data, ownership of the information, ownership of the patents, as well as we want to have obviously proof of concept. And if we've got proof of concept and that can be secured in some shape or form, then people would be more likely to be using our particular supply chains and have trust in it, as well as the system that we develop within the supply chains can be commercialized, and it can also be, shall we say, moved over to other supply chains and entrenched in a whole range of different areas. Then obviously making use of data analytics, and we've heard quite a lot about that in today's talk so far. And when we start to look at the analytics, it means really that we're going to find methodologies of comparing which methods are better, which methods are not so good. As we saw in the previous speaker's talk, there was a tremendous amount of data analytics generated by using various methods. And we can use that to enhance and to reinform the AI systems that we are proposing, but even before that, to inform our lattice networks. Now, with knowledge engineering and digital trust, knowledge engineering really means developing generating reactive systems, and with AI, which we are looking at being a very crucial element going forward, looking at identifying the various points of protection, but also informing the AI systems of where those points are using our lattices. So we're really looking at, and let's just get our drawing system going here. We want to look at the AI systems for proactive, using algorithms that are developed as a result of some kind of predictive analytics that we're going to be looking at going forward. Those of you that are familiar with formal concept and analysis will immediately recognize the diagram that we have on the slide here, and that would obviously would need some kind of testing once we develop the lattice or a number of lattices, and then obviously draw some kind. Can you all hear me?
Yes, we can hear you.
Okay, cool. All right, there was a momentary break in the communications. Just bear with me. Yeah, so our formal concept analysis, again, we would then obviously do probability analysis of the various points that are identified between our objects and our attributes. And remembering also that we then do an analysis. We'd run a number of models to analyze the intersections here and whether these are valid intersections for breaches within the supply chain. So it's really a work in progress here, and we still have a lot of work to do within the system over here, but it's very exciting work. So formal concept analysis really looks at a beacon of hope for us by mapping the focus points for our systems, AI systems. We not only reinforce integrity of the value chain, but also pave the way for future where trust is not just an ideal, but it's also a tangible reality. Now, in conclusion, we'd like to say that we'd like to do obviously to evaluate various probabilities, various points or breaches within the system, and so on. Now, last week I came across a very interesting, purely a newspaper. It's called Freight News. It features, it's a South African news that comes out daily, once a week. They bring up particular issues out there in the freight sector, which is all part of the supply chain or the logistics side of things. And they're now talking about embracing generative AI for survival and success. There have been a number of discussions by leading people, KPMG, also looking at generative AI tools to enhance the values which are created within the supply chain and to ensure on-time deliveries. And remember that within the supply chains, one of the major issues that they have is something called the bullwhip effect, which means that there are major ups and downs in the amount of raw materials that are flowing through the supply chain. They're also looking at trying to not so much digitize various aspects of the supply chain, but to automate. They're talking, as we all know, what Industry 4.0 is. Remember that supply chains are massive, and there's a lot of manual stuff still happening in the systems. What do customers want? Every customer is the next point of the link downstream within the supply chain, and customers are looking for on-time deliveries and their full order to be delivered when promised. The just-in-time system has contributed quite phenomenally to on-time deliveries, shall we say, that it's gone a step further than just in time, and it's moved into the area of just in time and in sequence. In other words, we're now running on the various supply chains in sequence, identifying products. You've got a white car, you've got a green car, you've got a green widget, you've got a red widget, and it's not batches any longer, it's single unit manufacturing. And then really there's a huge amount of planning and opportunities for running AI, for doing some of the manual stuff, but also for looking for breaches, data and information breaches, and IP within the supply chain. Because, as we said earlier on, just one patent has to be pulled out of the system, and it's going to create, it's really like a tsunami all the way through that supply chain. And yeah, there's a lot of innovation that we're looking at, to automate various processes within the supply chain, primarily at this stage, generating digital trust by having AI be a major driver within it. And finally, in conclusion to our talk today, we want to produce various measures, and we're going to then analyze these various methods against one another as to which models would be best suited for managing incursions into the supply chain and breaking digital trust. Guys, thank you very much, and hope you've enjoyed the presentation.
Hello. Hello. Am I audible?
Yeah, I can hear you.
Oh, thank you, Luis Kaplan, for a wonderful presentation. Actually, it's a bit different from those which we have heard so far, but of course, policy and such ideas are under this breaking session. So I think I want to give a chance for the attendees to ask questions, or if they have any suggestions, feel free to raise your hand and I'll give you the chance.
Thank you.
All right. Any question? Or anything you want to say?
What we found, if I can just interrupt for a moment, what we found is that a lot of AI has been is very technical from the perspective of, there's a lot of technical analysis, but there's also the world in which knowledge and intellectual property needs to be protected, and now we are looking for a way in which that we can protect the stuff by using AI as a tool.
Yeah, that's a wonderful idea, actually. If nobody is asking, let me ask you few questions just to understand. We talk about intellectual properties. Mostly the classical, traditional way is putting them into papers. We just publish them in form of patent or some form. So, is your idea also only concerned on the digitalized economy and knowledge flow, or does it contain anything which can be patented as an intellectual property?
Yeah, no, we're looking at anything that is intellectual property as well, to protect it, to create the digital trust, that people know that if they are buying or using or supplying intellectual property within that supply chain, that their material is protected.
Oh, I see.
Because there's huge amounts of these breaches, and there's the ability to, in a lot of instances, to reverse engineer IP.
Oh, I see. It looks a long supply and value chain, and I'm wondering if there is any prototype work you have ever seen, or any place which you can share as an experience. And another question. Yeah.
Not from the concept paper. I haven't seen this being used and developed at this point in time, but we're hoping to start to introduce it going forward.
Okay, and with the massive length of the supply chain, one of the challenges that we see is the intellectual property owner wants to benefit from any technologies or any ideas or methods that's brought, and we also want the users to use, or maybe the industry also use those, and at the same time make the proper payments. And anybody validating would be asked that question even legally. So it's the first time that I'm hearing such a thing. I really appreciate your idea. But I'm wondering if you have any mind, any model that you think of in terms of the learning algorithms or any architecture or systems that you uh, be would be willing to share. If there is any idea in you, that would be actually a good
Yeah,
point to discuss.
yeah, we've got some ideas that we want to test. Watch the space, and at the conference in a year's time, we'll share that with you.
Oh, that'd be nice. That'd be nice. Thank you.
Yeah,
Thank you very much.
we've
Thank
got
you.
we've got some ideas. We just want to keep them under wraps for now.
Sure, sure. Thank you very much. And I
Thanks.
think,
And that very philosophical question, which keeps getting asked, is
yeah.
should the IP be withheld from users? Should the IP not, or should we only generate money from IP, and is it for the benefit of society and so on? We're looking at the commercial side of it, and we're not going down that other route.
All right, all right. I think it looks like I have many questions, but we are limited this time. So let me just make a final remark. If Kiral, the technical committee, if you have anything to say, please. If not, let's make a final remark and close this session.
Thank you, Doctor. You can proceed with your final remark.
All right. Okay, thank you. Today is the second day for PanAfricon AI conference, which is held in Addis Ababa, Ethiopia, which is organized by Artificial Intelligence Institute. Um, and we heard in the morning the opening speech and also keynotes by different people. And in our section, the focus was mostly on cybersecurity, AI for cybersecurity and policy issues. And I think from the morning we saw around I think six plus six, 12 papers were presented, and it was ranging from applying deep learning for various domains, disease and others, and also in security. We have also seen works on IoT and how they should be. And in the afternoon, mostly it was we have seen the fake and real face discrimination using hybrid techniques. And now at last we heard from Bruce Kaplan how IP can be used in how AI can be used in protecting intellectual properties. And it's really interesting, and there is a take home from all of the presentations, and some of them are really technical, and some of them, as mentioned by the last presenter, was mostly philosophical at the same time, theoretical in their very nature, which needs more researching. So I want to thank all of you for coming, for taking your time to submit your work and at the same time present, and for all the attendees for your active participation and listening, also sharing your ideas. And if you need any connection, I think the emails are there. You can contact any of the research or topics interest you. Feel free to contact me, the technical committee members, or any presenter in here. I want to say thank you. Tomorrow, day two, we have other other discussion topics like the NLP, and there are also other two more topics which I don't remember now. But feel free to attend. The links are already available, and I want to say thank you, all of you. And with this, I think this will be the closing of the afternoon session. Thank you very much.
Thank you, Dr. Bakar, and thank you, everyone. And we'll continue our session tomorrow, and miss it not.
All right, all right. Thank you all.
Thank you, everyone. Really appreciate it. Thank you.